Hi, so this is the third video in the series where we're looking at the AQA higher paper, and it's actually it was sat on the 24th of May 2018, but it's the June series, and it's paper 1 non-calculator. In the previous video we got through to question 18, so we're going to have a look at question number 19. Like before, what I suggest is that you stop the video, have a go at some of the questions, and then compare your solution with the solution on the video. Okay, so type A batteries and type B batteries are tested. Information shows cumulative frequency diagram about the life of battery A, and then it says estimate the interquartile range. Now I'm very aware this is not going to show up particularly well on the video, but I'll do my best, because basically what we're looking at with the interquartile range is we can work out the median value, okay, which is going to be, if there's 80 batteries, it's actually going to be the 40th battery, or so that will give you an interquartile range, I beg your pardon, the median range of that one. Okay, so if we know that that's the median range, then we need to know, or the median value, we need to know then the interquartile range. So it's actually going to be half of that again, because what we're looking to do is to create, if you like, almost like a bar chart, not a bar chart, a cat's whiskers diagram from this cumulative frequency. And you can see here that what I'm able to do is just create this box plot that looks almost taking the same pieces of information from the chart, and there we go, and that will give us then the ability to be able to work out the IQ range, which is going to be the difference between this and this. So the interquartile range is 1400 minus 1100, so that's an interquartile range of 300 hours, and that would be the answer to this particular question. Okay, we might need to keep referring back to the diagram for question number 2, but it basically says then that we're going to look at the number of batteries of type A that have a battery life of more than 1600 hours. Okay, so a little bit tricky, but if you go back to the diagram itself, what we're saying is for 1600 hours it's going to be these batteries here. Okay, so if I take this across, it's actually going to be the batteries in that range there. Now each of those little squares is actually worth 2 batteries, so I would say for the batteries that have got a battery life of more than 1600 hours, it's going to be 4 batteries. It's 2 little squares. Okay, great. So let's have a look then at the box plot for the battery life of type B. Now the reason I usually, when I have cumulative frequency diagrams, I usually end up drawing a box plot, because I know sometimes on these type of questions a box plot of another type of battery or another type of this particular item will turn up. And it says on average which type of battery has the greatest battery life. Well, actually I'm going to go for battery B. Now the reason I'm going to go for battery B is because if I look at the range, I've got 840 to 1760, and if I take one away from the other, I'm going to get 1440 hours. Okay, and if I go back to my original, okay, what I can see on my original is that actually the range is going to be the difference from there, which is 840, through to here, which is going to be 1400 or so. Where are we? So that's going to be 1720, I beg your pardon, 1720. And the difference between this one and this one, if I just write back onto here, I've got the difference with type A is going to be 840 still, but the highest value is 1720, so that's actually going to be 1400 and 1400 hours, I beg your pardon, 40, and this is 1740. That's more like it. 1400 hours. Okay, so I'm going to get slightly more with type B battery, which is 1440 hours. Okay, so therefore this is a B and this is A. Okay, so I would on average say that battery B has got the greater battery life. Using data from both diagrams state how you chose your answer. Okay, well, the way I would choose my answer is to basically take this information and write it out on here, and I would say that the IQ range shows an increase of the full range shows an increase of 40 hours. Okay, something like that. All right, and obviously I would actually put that little bit of information in this line, but I wanted to keep it close to the box plot so you could see exactly what I'd done. Okay, so let's have a look then at question number 20. On this particular question, it's starting to get a little bit more challenging now. On this particular question, we're looking at sequences. Okay, and it says that we've got 3 terms of a linear sequence. So in other words, this is the first term, the second term and the third term, and it says the second term has a value of 8, so we can actually use that piece of information. And also then the fifth term has a value of 44. But what's the difference? What is the common difference with all of these terms? Well, with each of them I'm adding 4b. Okay, so plus 4b. So if I want to know the value of the fourth term, is going to be a plus 14b, and the value of the fifth term is going to be a plus 18b. Okay, hopefully you can see that each time what I'm doing is I'm adding 4b to each of these terms. Okay, so we're in a position now where we've got 2 simultaneous equations. So the second term has a value of 8. Well, the second term is a plus 6b, and that equals 8. Okay, and then it says the fifth term has a value of 44. So that's fine because that's 8 plus 18b, and that equals 44. Okay, now a couple of things you can do with this. I'm just going to solve it simultaneously, and I can either decide that I'm going to make both of these numbers 18, or I could just take one from the other and work out the value of B on its own. Okay, what I think I might do with this, just to sort of give you a little bit of a challenge here, I'm actually going to multiply this one by 3. I could, if I wanted to, as I say, just take the a's away, but I think instead I'm just going to do something slightly different. I'm going to write that as 3a plus 18b equals 24, okay? And I'm going to write this one as a plus 18b equals 44, okay? If I take one away from the other, I'm going to get 3a minus a is going to be 2a. 18b minus 18b is going to go. And I've got 24 minus 44 is 20, okay? So therefore, if I divide both sides through by 2, I'm going to get a equals, beg your pardon, that's minus 20. A is going to equal minus 10, all right? So now I can take that value of minus 10 and I can substitute it back into whichever equation I particularly choose, okay? Well, the one I'm going to choose, I can choose that one, that one, that one, or that one, doesn't really matter to me. I'm just going to choose the first one. So rather than writing a plus 6b equals 8, I'm going to write minus 10 because that's the value of a, plus 6b equals 8. Okay, I'm going to add 10 to both sides, so I get 6b equals 18. So divide through by 6, it means that b equals 3. So I've got my two values. I've got a equals minus 10 and b equals 3. And if I look at the answers at the bottom there, I could write those in, but I'm just going to write this in as a equals minus 10 and b equals 3. And that would be the answer to this particular question. Okay, let's have a look then at the next question, which is going to be question number 21. Now in question number 21, I've actually got an enlargement to do. This is going to be quite tricky to show this actually on the screen, but I will do my best to be able to draw this in a way that kind of makes sense to you. Okay, and I'm just looking around for a ruler, and I don't think I've got one. No. Yes, I have. Okay, so I've got a ruler. I could stop the tape there, but I'm not going to. Okay, all right. So the easiest way to deal with these is to draw actually the lines of enlargement. Now the lines are going to go through this center for 1, okay? And they're going to go from each of the points, each of the corners. They call them vertices. So each of the corners of this particular triangle, I'm going to have these lines that are going to go through. And that's first one is going to go like that. Second one will go straight across like this. And then the third one will go again through the center of enlargement like that. Okay. All right. Now, effectively, I'm using vectors to be able to get to each of the vertices. Okay, so what I'm saying is that if I want to go to A and I want to go as a vector, I'm going to go along 4 and then I'm not going to go up or down anywhere, so it's just going to be 4, 0. Okay, now I need to be in a position where I'm actually going to make this -2 times bigger. So if I multiply that by -2, what I end up with is -8, 0. Okay, so rather than going along 4 and down 0, I'm going to go along -8 and then down 0. Okay, so again, go back to the center. I'm going to take 4, 8 jumps back. So what was A is now A prime. Okay, so let's have a look then at B. All right, so if I want to get to B, what I'm going to do is I'm going to go along 2 and down 2. So if I write that as a vector, it's going to be 2 -2. Okay, and again, I'm going to multiply that by -2, and I'm going to get my new vector, which is going to be 2 times -2 is going to be -4. And -2 times -2, remember a minus times a minus is a positive, so that's going to be 4. Okay, so let's have a look at how that's going to work on my diagram. So again, I'm going to go back to my center, and this time I'm going to go -4 along and up 4, okay, 4, 4. So what was B is now going to be B prime. Okay, final one is going to be C. So with C, okay, let's have a look at how I'm going to get there. I'm going to move along 3 and down 2. So the vector for C is going to be 3 positive and -2 because I'm going down. Multiply that by -2 and I'm going to get 6 -4. Okay, so the vector itself will move along to 6. So 4, 5, 6. And then it's going to go... sorry, beg your pardon, that's going to be -6. And that's going to be +4. So it's going to be -6 and then +4. So it's going to go to there, which is C prime. Okay, so I've now got my 3 vertices of this particular new triangle. And if I draw lines to connect all of that, I'm going to end up with a triangle that looks like this, and this is the enlargement to a scale factor of -2. Okay, I hope that's useful to you and you're okay with that. There is a playlist on this particular channel with other examples of that type of enlargement if you wanted to have a look at it. Okay, so we're 14 minutes into the video. Let's have a look then at question number 22. So question number 22, I need to work out which of these represents the shaded region. Okay, so this is a Venn diagrams question. So let's have a look at what we've actually got. Okay, so the first one is, if I want to look at just this center one, you can see here that I've got A shaded. So if I just did that as a Venn diagram, okay, what I could do is I could actually shade that whole area in, okay, and that would be the value of A, okay. And then if I look at everything else, I've got this area here, okay, plus A as well. So if I look at the outside or the rest of the diagram, I've got then this area which is shaded in, which we know, okay, and then all this area around the outside, okay, plus that, and that's actually going to be not B, okay. So if I put, I know that's included in that, but if I put one over the top of each other, what I actually end up with is this diagram here. So the area that's represented by the shaded region is going to be A or not B, okay. It's actually that one. Okay, so let's move. Okay, so this is question number 23. This is probably going to be the last question in this particular video. Okay, so it takes a little bit of time to kind of work your way through this particular one. And then it says, so a shopkeeper increases or compares the income from sales of a laptop in March and April. By what fraction does the income from these sales decrease in April? Okay, I must admit I found this quite tricky myself, but what I think they're getting at is that if we look at March, okay, let's assume that March is one whole. Okay, that means that from a price perspective, it would be 5/5, and in April, because it's 1/5 more, it would be 6/5. Okay, so what we're saying is this is one whole, if you like, or 100%. If it increases by 1/5 in April, then it would be 6/5, or if you prefer 1.2, you could write it as that if you wanted to. Okay, so let's have a look then at the number. Okay, so with the number, again, we're actually now working in quarters. So I'm going to start with a whole, which is 4/4. And that meant that if there was a quarter less in March, then it meant there would be 3/4 of the amount of laptops sold. Okay, so we can then be in a position where we can work out that the price is going to be that the price is going to be, if you like, 100% in March. Okay, so the price in March and the number in March is going to be 5/5 times 4/4, which is going to be 20/20. So if you like, in March, the price is 100%. Okay. But what we've done in April is we've increased the value of the products, the value of the laptops, by 1/5 or 20%, but we've actually sold only 3/4 of the volume that we sold in the previous month. So we can look at the same calculation, but this time it's going to be 6/5 because we've got a 20% increase in April, but a quarter reduction in April. Okay, so 6 times 3 is going to be 18/20 as well. What that means then is that the reduction is going to be one minus the other. So it's this, which is a whole, minus the 18/20. So that's going to give us 2/20, which is 1/10, which is 10%. So the fraction of the income that has decreased in April is going to be 1/10. Okay. Quite tricky, that particular one, so I think it's probably worthwhile just stopping at this particular point, giving you the opportunity just to kind of work your way yourself through this kind of reasoning. A little bit difficult because sometimes not everybody is that comfortable with dealing with fractions, but I do hope that you found that particular one useful. We'll have a look at the question 24 in the next video, and I look forward to seeing you then.